This is the plan. What we're going to do is we're, in effect, going to iterate this procedure. So first, I'm going to tell you about the flat version of the case, which is going to be that. So it's a construction that happens on the plane. And then just like we wrapped this construction around a circle, what we're going to do is we're going to wrap that beast over there around a melon, which I brought today. We're going to do a sketch of the proof. So my objective is not to spell out all the details, because it would take longer than we have. It's just to have you guys understand how the proof works. And I think that you will understand how the proof works, because the basic idea truly is very, very simple. OK, so forget about the melon for now, and let's look at that beast there, which is called the Kiley graph. This is how the Kiley graph works. So you start at the origin, and then you're going to travel a certain path. And there are 4 directions in which you can travel. You can travel up, down, right, and left. There's one thing that's not allowed. You can't travel in one direction and then have the next thing you do be the exact reverse. So we're not allowing that. But with that exception, you can take any path you want. So for example, you can go right, and then down, and then left, and then up, and then left, and then left, and then left, and then left, and left, and then up, and then right, and then right, and then right, and then up, and so forth, whatever you want. And you do it one time for every natural number. Now, the reason this doesn't have an infinite size is because each step is half as long as the previous step. So maybe that step is half a meter, which means that whichever direction you choose to travel next, you're going to travel a quarter of a meter. And after that, an eighth of a meter, and a 16th of a meter, and so forth. So suppose, for example, that you decide to always travel right. Then you're going to travel a half, plus a fourth, plus an eighth, plus 16th, and so forth. So if you just keep going, you will have eventually traveled a meter. OK, so what we're going to do is we're going to take this piece here, divide it into a finite number of pieces, and reassemble it so as to get 2 copies. Now, in this experiment, we're going to do something that would have been a cheat for the melon. In this experiment, we are going to stretch. But the stretching that we're going to do here is going to be unnecessary when we get to the melon. OK, so here is the way to do it. So first of all, focus just on the vertices. Focus just on the points. Don't worry about the lines. So I drew the lines here just to make the graph intelligible. But you really were just worried about the points. And then divide the points into 4 quadrants. So that branch there is the left quadrant. That branch is the bottom quadrant. Sorry, I said right, left, up, and down. I didn't draw it perfectly, so I'm not sure if this will be evident. But a crucial feature of this graph is that that quadrant there, that branch, is a copy of the entire graph except for the left branch. So think of it this way. Start by just looking at the entire graph except for the left branch. It has 3 main stems, and from each stem you have a bunch of other things growing. But that's true of this guy too. It has 3 main stems, and from each stem it has a bunch of stuff growing. And of course, the same is true of any other branch. So if you take any branch, that's going to be just like the rest of the graph minus the quadrant opposite to it. So here is how we can divide this beast into pieces and reassemble it into two versions of the graph. So what you do is we're going to build one copy of the graph out of this quadrant and that quadrant, and another one out of this quadrant and that quadrant. So for the first one, what we do is we take that and we expand it. So each of its main branches is 1/4 of a meter long. We're going to expand it so that it's 1/2 a meter long. So we get that. And then we expand everything else accordingly. And then we take that quadrant as is and just append it over here. And we're done. We have a copy of the entire graph. And we do the same thing for up or down.